This is the notes for topic 1.7 on how to do conversions with derived units. So what we've been working with so far are units that you can measure directly, like meters. You can use a meter stick. Same thing with centimeters. You can measure seconds with a stopwatch. Everything, again, you have a device that you can measure each of those directly. Derived units are going to be ones that you can't necessarily measure directly, but again, can be kind of one of two things, either containing two units of measurement, or you're going to see like an example 2 and 3 going from, say, a cubic volume to another cubic volume. So we're going to work through a few examples on how to do these. So the first thing is, when we look at this first one, is we have this car that is traveling at 65 miles per hour, and we want to know what is the speed in feet per second. So the thing that's going to be different now is the setup's all going to be same, and how to cancel units are going to be the same, except we are going to be converting two things at once. So remember, this line, we read it as per, and that means divide. So when I start, what I'm going to do is I'm going to have 65 miles in the numerator, and we have to separate these units in order for units to align and cancel. So this says per hour, so this will always be whatever it's per something, it's always one of it. So we're talking about 1 hour. Okay. So now we need to change it to two different things. We need a new distance unit here, feet, and we need a new time unit, seconds. It doesn't matter which one you convert first. I prefer to convert the first distance unit, whatever's in my numerator is what I like to change first. So I'm going to work on how to change miles into feet first. On your Holy Grail sheet, go ahead and add this conversion factor. 1 mile is 5,280 feet long. So again, go ahead and add that to your purple or printed Holy Grail sheet. So from here, we can go ahead and start thinking about how to set these things up. So I have 1 mile here. Nothing has changed with what we've done so far. 1 mile is going to go in the bottom, the denominator, 5,280 feet in the top. Again, what I'm looking for is that my miles unit has canceled, and I'm now at feet. So I know that this part of my problem is done. Like when we've had problems where it takes more than one step to solve, you can continue to just add on to this conversion. So now we can work with the time component and changing time into seconds. Again, you can do that right away. Again, I prefer to do whatever's in the numerator first. This part you do have to be careful on, because you have to remember hours is in the denominator. That means hours needs to go in the numerator to cancel. Again, we're representing that because they are dividing to cancel. So we need to break hours into seconds. So the most logical thing to break this into is minutes first. Again, what I'm looking for here is that hours is going to cancel. I'm not done because, again, this problem is looking for seconds. So I know I need to add one more step. Again, because minutes is in the denominator, I'm going to put 1 minute in the top, 60 seconds in the bottom. I do see that minutes lined up to cancel. What I have left is feet per second, and that's how I know that I've completed that. This is where it becomes important to kind of solve it in two steps. So go ahead and multiply 65 times 5,280. Don't worry about sig figs until we get all the way to the end. So what we get here is 343,200. Okay. In the bottom, multiply everything across. So 60 times 60 gives us 3,600. Looking at our original given, this per hour isn't going to give us our sig figs. This 65 is. So that has 2 sig figs to start. So when we divide it out to get our answer, rounded to two significant figures, we get 95. Again, I'm left with feet per second. And that's my final answer. In the next example, it looks more intimidating than it really truly is. So it tells us to convert 3,800 cubic millimeters into cubic centimeters. So what we're going to do next is start with our given. So we have 3,800 cubic millimeters. This is a volume measurement. So again, you can't directly measure the volume. You can measure, say this is a cubic object, that you can measure the length, width, and height, then use the volume formula to then solve for that. That's what we mean by derived. So this is a lot like your metric conversions. If you just cover up that cubed part, it's looking like millimeters to centimeters. So if you remember, this is a prefix to prefix conversion. And I had you guys do that little roadmap: prefix, base unit, back to prefix. So that means you're going to convert millimeters to meters to centimeters. So really the only thing that's going to be different is we are working with volume, so these are going to be cubed. So the first thing you're going to do is use your Holy Grail sheet to find the conversion factor between these two. When you do that, you're going to find that there is 1,000 millimeters in 1 meter. So what do we do now that it's cubed? So we have millimeters here. So the 1,000 millimeters will go in the bottom. 1 meter goes in the top. So to address that, we're going to cube each of these. I like to put them inside parentheses with the cube outside. That is my reminder to understand that this is already cubed. I'm not doing anything to that. The unit is measuring, again, a volume. These, to represent a volume, must be cubed. Now the next step is to go from meters to centimeters. So find your conversion factor at the top of your metric sheet, and you'll find 1 meter is to 100 centimeters. So that means, given here we have meter, so 1 meter is going to go in the bottom and 100 centimeters in the top. Like the last step, we're going to cube these. So again, when you go to type this in, this is already measuring a volume that has had its length, width, and height multiplied, so we're not cubing this. That's representing the unit here. The conversion factors are not representing that, so we need to cube those. So what you would do on your calculator is you're going to type in your 3,800 or 3,800 times, well, 1 cubed is 1, and so then we have 100 to the power of 3. Okay, so the next thing is I would recommend putting your calculator into scientific notation mode. If you have a graphing calculator to do that, you're going to go to mode, and then you should see these 3 options: normal, sci, and English. You want it in scientific mode. However, when you go to your math class, your math teachers are not going to appreciate scientific notation quite like I do. So you want to make sure that you put it back to normal in order for your answers to come out in this format. Scientific, that E again represents times 10. So I know there's lots of different calculator modes out there. If you want to learn how to put your calculator into scientific notation mode, feel free to take a picture of it and send it to me. If you are one of my students that's in class, just bring your calculator to class and I can show you when you are here, or I'm sure you can find something online that will walk you through it too. So what I'm going to write then for the top is scientific notation, because I'm going to save myself that headache. So 3.8 times 10 to the 9th. So the bottom, we're going to do 1,000 to the power of 3. And if you think about it, I guess I wasn't looking close at my units. I don't need to do that part, so I'm just taking 1,000 cubed, which is 1 million, or 1 times 10 to the 9th. So I'm going to divide those out. So 3.8 using my EE key, 9 divided by 1, EE, 9. So then see how it says E0? That means times 10 to the 0. So really what my answer is telling me is that it is 3.8. This has 2 sig figs. 3.8 has 2 sig figs. Let's look for unit cancellation. Millimeters cubed eliminate, meters eliminate at centimeters cubed. So we are now solved and good to go. So I would recommend take a second, pause the video, and see if you can try to figure out number 3, and then unpause the video and see how it goes. So when you go to set up number 3, you have 43.4 centimeters squared in this particular situation. So what I recommend you do is just cover up that exponent, kind of ignore that. What this is telling you to do is convert centimeters into inches. So you're going to use your Holy Grail sheet to find that conversion factor. What you're going to find is, because I have centimeters as my given, I'm going to put that 2.54 centimeters in the denominator is to 1 inch. The difference between example 2 and 3 is that in this case we were going to a volume cubed. Here we're basically finding area since it's squared. So instead of cubing, we're going to square. This is going to be just a one-step problem. Again, your units decide that. Centimeters canceled, so we're left with inches. So on your calculator, all that you need to do is get 2.54 squared. Notice again e to the 0 on my screen, so that means times 10 to the 0. And this isn't going to change anything, and we are not squaring this because, again, it's already a derived unit. So we have 43.4, and that is all we're going to have in the numerator. And in the bottom, I'm going to have the 6.4516. Now I'm going to divide those out. Notice my times 10 to the 0. This has 3 sig figs. So my answer should have 3 sig figs. So my final answer is going to be 6.73. I'm left with inches squared. And that, again, is a problem that's completed. So now we're back to an example much like example 1, where we have 2 units. So density, and this is going to be something we're going to talk about here shortly, we are changing 2 things about it. We're changing the mass from grams to kilograms, and volume from milliliters to cubic meters. So again, the first thing that you want to do when you go to set this up is write your given. So 19.32 grams per 1 milliliter. So again, you have 2 options. I'm going to start by changing grams to kilograms. And this part's going to go pretty easy because we're not working with anything changing an area or volume. So we just need to go grams to kilograms. So using your Holy Grail sheet, you'll find that 1,000 grams is to 1 kilogram. Because grams is in the top, 1,000 grams in the bottom, 1 kilogram in the top. This part of my conversion is done. I've got it to the unit I want. Now I need to start working on this milliliter to cubic meters. And actually, let me just grab a Holy Grail sheet real quick. Okay, where you're going to find this, and you may want to highlight it or put a big star next to it, is this conversion factor right here. We haven't really used this part of the Holy Grail sheet, but this really becomes important with a few things that we do with density and measurements. So if you have 1 milliliter of water, you can assume that its volume is equal to 1 cubic centimeter, which is equal to 1 gram. We're going to use this scenario with our gold, but again, this is more of a constant for water. Okay, so what I have right now is we're going from milliliters, which is, again, if you think about it, something that we use to measure more like liquids. And then cubic meters is more used for something that you can measure dimensions, something that I call a regular object like a cube. So where we're at now is we have milliliters. So 1 milliliter is going to be in the top is to 1 cubic centimeter. Okay. Where we can go to next then is milliliters cancels. We're at cubic centimeters. So then we just need to get it out to cubic meters. So centimeters is in the bottom. So 100 centimeters is going to go in the top is to 1 meter. Again, to then take care of that cubic part, we are going to cube each of these in the end. Start simplifying it out. So we're going to take 19.32 times 100 cubed. So what you get there is 1.932 times 10 to the 7th. In the bottom, all we need to do is take essentially 1,000 is the only part that's going to carry on. You're going to divide these out. Our given has 4 sig figs, so our final answer can have 4. So once it's divided, we get 1.932 times 10 to the 4th. Again, let's see if I canceled all my units. I forgot to put a slash through here. I'm left with kilograms, cubic meters, and we are all done. So you have a homework assignment working through using this style of solving. If you're unsure, especially if you guys are a remote learner and you don't see me face to face, you can always take a picture of a particular problem that you're stumped on. You can send it to me in an email and I can gladly look it over for you. Same thing if you just want to double check something. Like I said, just send me a Google Hangout or send me an email. Otherwise, good luck on your homework.